Thank you so much, Mr. Haroon. Thank you so much for giving me this opportunity to speak for SMEDA. Am I audible to you? First question, and can you see my screen? Right. Okay, so let me start today's discussion. So the topic on the anvil today is energy saving opportunities in agriculture using renewable energy technologies and smart farming in Pakistan. As Mr. Haroon mentioned, my name is Muaz Altaf and I'm an energy auditor. So that's my brief profile. I am a PhD candidate right now in the field of energy technology at King Mongkut University, Thailand. Prior to that, I did master's degree in energy engineering from Asian Institute of Technology, Thailand. I also hold MBA from the Institute of Camilo Jose University in Spain and a bachelor's from electrical engineering from BTH, Sweden. So overall, I have a 7 years of work experience, including 3 years of work experience in the field of energy. So in today's discussion, I'm going to talk about agrivoltaics, number 2, solar heat for farming practices, smart farming practices using IoT, and smart agriculture in Pakistan. So let's go to part 1, which is the introduction to agrivoltaics. Now, if you see the term agrivoltaics, you see agri is related to food production, and which is agriculture, short of agriculture, and voltaic is related to electricity production. So when we talk about the nexus of water, energy, and food, and when we talk about food, agriculture comes first. These are the important 3 aspects of modern civilization. And we have been advancing a lot of technologies, components separately to address these components at once. Now it's time to step back and reimagine their relationship, because we have been talking about climate change and a lot of stuff. So the nexus of water, energy, and food is very important. So when we talk about this agrivoltaics, this technology promises to improve food production and reduce the usage of water. And it also create energy and additional revenue for you, and it will save energy also. The solar panels placed on the land where you grow crops allow you to grow and harvest the power of the sun twice. How? We are going to have a look at that. As you know, that agriculture uses enormous amount of resources. It takes a lot of water, energy to grow food. So 85% of global water consumption is used for irrigation for crops, and over 1/3 of all greenhouse gases emissions are attributed to agricultural sector. But at the same time, having said that, we know that the demand for food is growing. Our population now ticks at around 7.5 billion. Soon it will be 8 billion, and by 2050, it's estimated to be 9.8 billion, which is around 10 billion. So if that scenario, we need to nearly double our current food production to meet that demand. And we also, not only that, we also improve access to this food so that there won't be any malnutrition people around the world. For that, we need to reduce food waste and address inequities related to food deserts. Now, when we talk about food, it's a complicated term, and the approach to it is dynamic, and sustainable food is not just one term, but it's multifaceted. And for the next 90 minutes, let's focus on future production and resource management side of food. Sorry, I have to. Okay. Can you see my screen now? Hello?
Yes, I can see your screen now.
Thank you. So why is it important? You see, If you see the water issue alone, and you know that as I discussed already, that the agricultural demand is increasing. So we don't have enough land and water to address to our increasing demand of food production by 2050. And we are all aware that high cost of fossil fuels on both our wallets and the environment. So if this status quo remains, we will likely to face more food shortages, which in turn will cause social unrest and potential economic collapse and environmental issues, of course. So in order to meet the dynamic needs of the changing society, we need to come up with new technologies, innovation driven technologies in these fields, from tractors to pest management to breeding and genomics, which we also called as genetically modified food. So today, most farmers, they are accustomed to exploring new methods to address these challenges in agriculture, and they are looking forward to mitigate risk that were brought on by changing climate issues. In South Asia and in Pakistan in particular, people use kerosene, diesel, and propane to power generators in the field of agricultural operations. These systems can give power for a while, but there are drawbacks. Like, for example, fuel has to be transported to generator's location, and that some distance has to be covered on challenging roads and landscape. The noise and fumes that can disturb livestock and, of course, human. Add up fuel cost and spill that can contaminate the land, and the generators that require significant amount of maintenance. And like all mechanical systems, they break down and need replacement parts that are not easily available. And also, if you use propane or bottle gas to heat water for pen cleaning or the house or the houses of the livestock or crop processing drying, it may pose safety threats. So what's the alternative? Agrivoltaic is the solution. The alternative is solar energy. If we use the modern, well-designed, simple to maintain solar system to provide the energy that is needed, when it is needed, and where it's needed, we can address these issues. These systems have been tested time and time again and proven around the world to be cost effective and reliable. And they are raising level of agricultural productivity worldwide. So the solar panel also help plants grow more efficiently by needing less water. Now, how exactly do solar panels help plant use less water? This is a very important question. And if we want to understand that, we have to understand the photosynthesis process. Plants have a limit to how much sun they can actually use. This is called the light saturation point. Once you reach the light saturation point, any light beyond that point does not increase photosynthesis or help the plant to grow. Rather, it increases the water demand for the plant, because beyond that point, more light makes the plant to sweat and thirsty also, which in turn requires it to consume more water. So if we have the solar panel that is positioned in a certain way that allow plants to receive just the right amount of sunlight, and then excess sunlight that can be harvested for electricity and produce more than that they would without crops below them. So now we have these moving solar panels also. Plants in turn, they are under the solar panel. They help the solar panel to keep cool, which increases their efficiency and productivity. A study conducted at Oregon University has shown that panels positioned above plant produce up to 10% more electricity than the normal production. So what are types of solar that we have? There are two types of solar systems that we have. One that converts solar energy to DC power, and those that convert to solar energy to heat. Now, both of these applications have their usages in agricultural setting, making life easier and helping to increase the productivity when it comes to agriculture. Agrivoltaics is a symbiotic relation where both the solar panels and the crops benefit because they help each other, as we discussed or earlier, that solar panel does not let plants consume more than the light saturation point, and at the same time plants keep the solar panel cool, which helps them to increase their productivity. So this way the electricity that is produced can be used to run farm with electric tractors, equipment, and to power precision agriculture technology that helps further reduce water usage. If you have more energy production than that, then it can be stored in battery banks or sent back to grid for consumer use. In any case, it's a win-win relationship between three most fundamental elements of modern life: food, water, and energy. Talking about the solar generated electric photovoltaics, PV. It's called PV. They are solar cells that convert sunlight to DC electricity. The solar cells in a PV module are made from semiconductor materials, and when the light energy strikes the cells, electrons are knocked loose from the material's atom. Then what happened that there are electric conductors attached to the positive and negative side of the material. They allow electrons to be captured in the form of a DC current. This electricity can then be used to power any load, such as water pump, or it can be stored in a battery for future use. What about energy storage? It's another application of agrivoltaics. It's a simple fact that PV modules produce electricity when the sun is shining. It's intermittent. So some form of energy storage is necessary to operate system at night or in a cloudy weather when sun is not available. So what you can do that you can store this energy and you can pump the water into tank using this energy and distribute it using the help of gravity, using gravity when it's needed after dark. And if you need electrical applications at night, you can use battery to store the energy generated during the day. PV is a well-established, proven technology with substantial international industry network. It's increasingly more cost-effective compared to both extended electrical grid and generators in remote locations. And normally the agricultural lands are in off-grid; they are in remote locations. Moreover, PV systems are economical in providing electricity at remote locations on farms, ranches, orchards, and other agricultural operations. When we talk about remote location, it can be as little as 50 meters from an existing power resource or a grid. PV systems can be cheaper than installing power lines or step-down transformers in applications such as electrical fencing, area or building lighting, water pumping, either if it's for water, live water watering or crop irrigation. So it's better and economical in both ways. So when we talk about another application of water pumping, you can see here that this motor and centrifugal pump is connected to the power panel. So it is operated through the power generated by the PV panel. So it pumps the water back to the water tower, and from there it can be distributed using the gravity, as I mentioned earlier. So once you pump once you pump the water in the water tower and it's full, you can use it even during the day, night, or in a cloudy weather when the sun is not available. So these systems have an added advantage of storing water for use when the sun isn't shining, it's dark, it's cloudy, and it eliminates the need for batteries. It enhances simplicity and reduces overall system costs. It can also be used for other powering appliances like electric fans for air circulation. And you may know that modern cattle and poultry farms can even double and triple their production by raising the animals in enclosed buildings, which is powered by PV panels. So another good use is the lighting in agriculture buildings and enclosures, as we mentioned earlier. So if you run the electric wiring from the grid to an outbuilding, that can be an expensive alternate, but yet lighting in these buildings can significantly extend working hours and increase productivity, especially for those who use precious evening hours for equipment repair and maintenance. However, PV systems, they have their own advantage. They are economical choices than conventional battery powered fixture, flashlight, fuel lamps. In addition, they are environmental friendly. They provide more light. They are good in quality, and they emit no smoke or fumes. Hence, they are environmental friendly, as mentioned earlier. What are other further uses of PV? They generate power for to feed or product grinding. They use electric powered egg collection and handling equipment. They can be used for product refrigeration. They can be used for livestock feeder and sprayer motors and controls. Hence, also they can be used for compressor pumps, for fish farming, for water tanks. They can be used for electric fencing to contain livestock within a certain area. And also they can be used for battery charging. So there are many uses of PV. And now moving on to the part 2 of this presentation, using solar heat in farming practices. Now you can see here, we have this solar crop dryer. So traditionally, what farmers used to do, they used to dry crops and grains by simply exposing them to the heat of the sun in outside. However, by allowing crops to dry naturally in the field, exposes them to the elements and contamination like birds, insects, and even rain. So that won't help them. We have this solar crop dryers. So there are some certain trays here. You can put the crops in the dryer in the trays, and this is the solar collector that gets the solar energy, and it gets warmed using the dryer and the enclosure. The air passes through it from here, and that air becomes very warm and passes through it and exits through the chimneys. And when it passes through these ducts and the trays before passing chimneys, it dries the crops. And hence it's again very environmental friendly and cheaper in use. Another use is water heating. So this is something we particularly need for our livestock operations. For example, if you are using poultry, chickens, so their houses, pens, and equipment must be cleaned periodically. Then simple water heater are available to provide low to medium temperature hot water for such purpose. Again, we do it through a solar collector, a storage tank, plumbing, and pumps. Commercially available systems are also available and offer simple installation. If you are using a commercially available solar water heater, it provides water at a temperature of around 60 degrees Celsius in any amount needed. So this system is economic, and it will help you to, the setup cost is very low, and it can be used the whole year round, even in winter. Well-designed systems normally provide no more than 50% of the annual hot water requirements. And this annual distribution pattern of solar radiation is measured in kilowatt-hour per meter square. Solar heating is long life with low maintenance. A recent survey conducted by DTI UK of 700 systems installed within the past 30 years showed that the majority of systems had no problem, and they work reliably for 20 to 25 years or more. A study carried out by Action Renewables in 2007 also reported that it took only 12 British pound per year to run the pump for a domestic system. So you can see how cheap it is. Only 12 British pound for the whole year for running the pump. That's the cost. And this will be greater for a farm scale system, but overall will not be significant cost. So even if it is a little more than that, it's still within the range. Payback period is also very good, which is around 10 years. And the modest return on capital, there are a number of factors that can affect the payback period. For example, a farm system used 365 years a day will be more efficient than a domestic system. A farm business can get a tax write-off on the initial investment, and changes in electricity prices will alter the payback time. Again, we have one more application which is very important, which is very vital, and that's the wind system. It can also be used in agriculture. Small wind system can provide power that can be used directly or stored in batteries. These systems are reliable in areas that get enough consistent wind. These systems are cost effective, reliable for many power needs on farms and ranches. So for example, if you see in some European countries like Holland and the Netherlands or Germany or even France, you will see wind systems installed even in these remote areas or agricultural farms. Moving on to part 3, smart farming using IoT. Now, I have talked a lot about the significance of farming. Our human need is growing, human need for food is growing, and by 2050 we would need to increase at least threefold of what we are producing right now. However, the old ways were not very reliable, and they used to do a lot of damage to the crops and to the environment, including flora and fauna. So if we want to keep maintain the right amount of food with minimal damages, we need to develop smart farming with IoT, Internet of Things. It's not only it won't only increase the productivity, but it's designed to bring more benefits like higher profit, efficient planting process, premium harvest, environmental friendly solutions, and more. Let's go into the details. IoT, or Internet of the Things, includes enhanced objects with technology in processing, sensors, cameras, and things that from where we can send and receive data to other networks. There have been examples of IoT in daily activities like home automation to saving energy, traffic control, NFC tagging, a lot. However, in terms of agriculture, technologies have also been involved and developed for a year, and it's called smart farming. So if we integrate between technology and farmer skills, that is aimed to produce the best quality and quantity of the commodity, because we are integrating the human effort and intelligence with modern technology, and that's what we are aiming at. So prior to that, human used to take all roles in farming, from planting, growing, harvesting, checking, so on. However, with the help of smart farming, some jobs are taken over by technology like sensor, drone monitoring, drone pest management, AI, robotics to optimize the process, and it's going to make the life of the farmers easier. How? There are different ways. So based on the function, I'm going to tell you about some techniques using technology for smart farming. Number one, field mapping or data collection. So sensor technology is set up to measure environmental aspects such as humidity, temperature, light, intensity, water, rainfall, soil composition, and more. And not only that, we are going to get predictions of these weather based on these technologies. But through sensor, we can get the live data by just using any computer or any device that we are operating. Then GPS and GIS support the bigger picture of the map by providing the geospatial data. Predictive analytics, as I mentioned earlier, then once we have this data, we use field mapping, several types of analytics softwares to predict and suggest the needed action, what needs to be done. And these systems are even equipped with alert system for discrepancies or pest attacks. So we can know in advance what's going to happen next based on the information and data that we are getting. If you want to save this data, you have the cloud-based system. So you don't need an on-site disk or something to record this data. We have cloud-based solutions. So you don't need to worry about data. You can do it on a wider area and analytics, and you can save it. Then live tracking and monitoring. It requires cameras, drones, tags, and GPS. Drones and camera provide a visual of the field. So you can monitor your field in 3D and at any angle by just sitting at your room. Then these tags and GPS supply precise coordinate location of the livestock as well. Labor work. So like similar to automation, drones and robotics have reduced the labor work, such as planting seeds, watering the plants, harvesting, spraying the pesticides, milking the cows, picking fruits, irrigating, and more. This all can be done with the help of robots, drones, etc. Then comes to warehousing. In tropical countries, farmers are utilizing solar powered refrigerators to store the fruits and vegetables right on the farm. So you don't need to bring your harvest to any place. You can refrigerate it on the site, on the farm, and for longer use. And these greens and fruits are prone to get withered. Storing them in fridges directly is a smart way to provide fresh commodities and keep them fresh for some time. Energy saving, it's going to help you with, if you are using automation, a lot of energy consumption can be cut down. Smart in irrigation can automatically turn the machine off when the sensors tell it that sufficient amount of water in the soil is reached. Then for pest control, drone spraying is there. So it makes also the life of the farmer very easier. So you just need to operate the drone for pest control only on the necessary spots to prevent polluting the land. So only where it's necessary, it will be done. In other parts, you don't need to do this. However, what you can do is that smart farming is with IoT is set up to overcome certain problems to reach some goals. There are many techniques. However, you need to identify the gap and what technologies, what proper technologies are needed in what areas. This is critical. And many parts of farming could be enhanced with technology like tags in cows, sensor in soils, picking robots that pick the fruits and harvest, and more. After you set up this technology, you need to check up regularly to see if your technology is performing well and what are the results that it's producing. What are the benefits then? You get improved products with high quality control and experiments. Nowadays, with using all these technologies, companies are producing vegetable with a certain taste that is different from other vegetables. The greens that you are getting are categorized as organic and pesticide free. With the help of precise data, tools, prediction, or action can be made using this precise data. Because certain plants are better in high temperature, so you can know in advance what crop you are going to grow next, how you are going to rotate the crops. These decisions come in easier rather than just guessing. The data hence can be saved and used in reference for your future use if there is a similar condition coming up in future as well. It's environmental friendly. If you can minimize pesticide use, irrigate water sufficiently, not over irrigated, not under irrigated, you manage the waste efficiency, you use good practices and save farming damages, then you are going to get good yield and you are helping the environment also. It is predicted that years from now, farmers could build a farm with varied commodities without removing the endemic flora and fauna, which is very, very important nowadays, because what we do is that we have to remove everything before growing a crop. Again, some benefits: efficient management and cost effectiveness. So labor work are done by these technologies. The management cost can be reduced or allocated to maintain this technology. So the amount of money that you are paying to the labor, you can invest in for the technology. The farmer could also be away, so can go anywhere. He or she doesn't have to be there all the time. However, he or she needs to keep controlling the farm from far away, from remote location. There is not much risk involved also, so there is low risk. This technology could predict disaster that might happen to the farm in terms of a viral diseases, climate changes, pest attack, and this information help the farmer to be well prepared in advance. However, there are some downsides of these things also. One of the downsides is that they are prone to be damaged. So if you are not taking good care of the technology can get broken by natural factors like heavy rain. Like, for example, if you are flying a drone, and if it in a heavy rain or strong wind, thunder strikes more, so it can be damaged, and that can be a big loss for the farmer. In that case, the maintenance cost is not cheap, with updates and future research needed. So what should an entrepreneur do in such case? They should identify the goals, and they should focus on what aspect they are going to focus on. Hence, they, after identify these goals and identifying the gaps, they prepare money and choose the suitable technology to address these issues. If they don't have enough finances, they can try to collaborate with other researchers, so they can do their research, and you in turn can get the best crops. Another way, if you don't want to collaborate with a researcher, you can find an investor. So after all this technology is already set, then you can maintain a smart farm. More research, however, regarding the actions need to be taken, and possible future technology must be carried. Smart farming with IoT is a growing business nowadays. So if you see, it is projected that the agriculture market in the US will grow at the annual rate of 19.3%. A survey also shows that technology installation in farming also helped in the growth rate by 20%. And this happens in many countries around the world, as they are coming up with modern innovation, including Japan, India, Canada, Colombia, Mexico, Brazil, Chile, and Argentina. So there are many South American countries involved in this also. Now that takes me to the final part of the presentation, part 4, which is smart farming practices in Pakistan. Before moving on to that one, we need to know some facts about our country, Pakistan. It's the world's 6th most populous country, and with the population growth of 2% per year. Most of the arable land or agricultural land is already in use. So we are running out of land. Why? Because the demand for our food is increasing, and rapid urbanization is not leaving us with enough land. So how we are going to address our food, growing demand of the food? That's a big challenge. So although Pakistan is making considerable efforts to incorporate renewable energy technologies into agricultural production systems. However, there are widespread energy shortages in the country. The country's economy has been growing steadily over the last 60 years at an average annual rate of 4.9%, and it has nearly doubled in size in only the last 10 years, from GDP of $137 billion back in 2006 to $270 billion in 2015. However, this growth has also been inconsistent, with many cycles of booms and busts. Agriculture remains the second largest economic sector in Pakistan, that contributes approximately 25% of the national gross domestic product, GDP. And it absorbs roughly 42% of the labor force, that is mainly composed on women. So if you see Pakistan's import and exports, so the exports were 4.29 million US dollar, 4,290 million US dollar, and out of which 50% consisted of rice, 8% consisted of cotton, 5% consisted of crude material, 5% wheat, and 2% mandarins. And what about the imports? That's clocking at 5,423 million US dollar. And I cannot understand why we have to import a lot of cotton from outside, 12%. and palm oil, 33% of palm oil. So it means that the productivity remains low with significant yield gaps compared to global average in key crops like wheat, rice, sugarcane, oil, and even cotton. The average farm size in Pakistan is 2.5 hectares, with approximately 43% of the farmer categorized as smallholders because they have less than 1 hectare of this land, and 22% own more than 3 hectares of land. So we are running out of land, as I mentioned earlier. Pakistan is a natural resource based economy with half of its total land of 36 million hectares dedicated to agriculture. Approximately 84% of land is classified as arable, which is agricultural able, and 14% as permanent meadows or pastures. So that's small. The country's forested area represent only 2% of the total land, which is, if you compare it to the world's average of 30%, it is declining at a rate of 0.2 to 0.5% per year, which is alarming. Hence, deforestation, which is driven by rapid urbanization, a rural reliance on fuel wood, and poor land planning has been linked with socio-economic vulnerability and a lack of effective policy and monitoring mechanism to protect forest. So with all this, we are running into more challenges like food security, nutrition, insufficient water resources for agriculture in Pakistan, and of course, insufficient land. So we need to employ smart farming practices in order to increase the crop yield, at least on the land what is already available to us, to meet the needs of the growing population in Pakistan. Smart agriculture method helps to provides a site-specific mapping of smaller agricultural field, crop vegetation, classification, yield, and health monitoring of the crop with the help of automatic field boundary detection and implication of clean satellite images in pixels. Hence, this data can be exploited for the extraction of crop-specific, reliable, spectral signature-based quantitative information for precise agronomic decision-making. And what are they? Number one, crop health monitoring. If you have IoT devices and special images using GIS that work together, it will help and enable farmers to monitor their crop for early detection and locate geo-specific anomalies, pest attack, diseases, and other deficiencies. It will help to deploy informed decision about sowing sites vulnerable to yield losses, pest, and quickly reacting to emerging problem of soil health, along with the optimized scouting, soil maintenance, and irrigation. So you can also check the soil, scout on the soil, how it's performing, and you can also take further decision about crop rotation, what crop to grow next based on the soil health and changing weather. Then after health monitoring comes the crop growth monitoring. If you have the continuous analysis of crops with the help of satellites, it will help you to distinguish growing crops from weakened and unhealthier ones. Sorry for the typo, it's weakened, the weaker ones and unhealthier ones. Hence, using smart tools, plant growth stages will be examined with the help of multispectral images. If you have this insight into plant count, canopy cover, and field potential, allows farmers to apply these inputs at appropriate stages of the growth of crop within the field. That is, distribution of drainage and irrigation systems, and selection of optimum time to apply fertilizers. Fungicides, pesticides tracks plant growth throughout the season for better prediction of the crop output. So you just won't leave anything to the chance. You can control things at every stage. Then the third stage is yield monitoring. So through satellite imagery and the AI data, artificial intelligence data tools, you provide distinct changes in vegetation and growth that is attributed to allowing analysis of various cultivars and adopting the most productive ones with the right quantity and the right time for seeding. If you know all this, it allows you to choose fields where they need to invest time and resources. Then is crop management. So this is based on the advisory tool that provides soil mapping, scouting of the soil, scheduling the irrigation, fertilization of the crop, nutrient management plan. This way, the farmer plan their input application to field that need the most appropriate applications. So if you have the historical data, you can make a comparative review of this data in a particular retrospective way that provides right choices of crop sowing for particular soil composition, intercropping rotation for production, and that will help you in higher yield and soil fertility, increasing soil fertility. Then crop harvesting alerts. If you are using the predictive analytics to harvest, forecast anomaly propagation in the surrounding, it will help you to get the information for harvesting and disintegrate healthy crops from unhealthy one. So that makes your life very easy. You don't have to do it manually, but rather using the predictive one, you can even forecast what's going to happen next. This survey helps to investigate infestation level, trends, action thresholds, and issue early weather forecast to take preventive measures, prepare you for harvesting, manage labor and machinery. It also avoid any unforeseen event like the one unfortunate event that happened in Pakistan, the flood. So if the farmers are using this one, they may get the alert in time that this is the right time to harvest and move the crop to another place. Then we have the carbon calculator. If you have the smart tools, horticulture integrates that with remote sensing, AI, IoT, data science. Crop health and food safety is bringing agriculture into the pace of reducing the greenhouse gases emission. Remote sensing provide unique insight to soil carbon store and soil health, while canopy coverage, yield mapping, and spatial monitoring of fields. It in turn helps the farmers in reducing crop tillage, maintenance of diverse nutrients into the soil, minimizing soil erosions, steps to make soil resilient by crop cover and crop biodiversity. So such data driven practices are needed, and if you use them, you will ultimately produce verified carbon credits. So how much environmental friendly it may become using smart farming practices. Then risk management. If you have water erosion and drought, these both things are harmful to the field productivity that leads to unfertile and unsuitable land for farming. The water level of the soil is predicted with the intensity of the microwave signal emitted or reflected by the Earth's surface, which is based on the ESA satellite measurements. Smart monitoring system provide insight of drought and flood intensity level with field level accuracy, control over immigration, mildew, and other moisture related threats. These things are very critical for your yield forecast. So actuarial analysis and early prediction of hazardous events such as floods, droughts, heat waves are needed in order to prevent the risk that may be related to your yield, crop yield. Another thing which is very important is weather uncertainty. So weather can be always intermittent, and because of climate change, the weather uncertainty has increased twofold. So in that case, you need IoT tools that are capable of large-scale environmental monitoring, including land use cover classification, measuring GHG emissions, weather forecast, and air quality. These tools can measure black carbon, nitrous oxide, CO2 level, methane, SO2 level, and particulate matter in both rural and urban setting using Sentinel 5P and other satellite sources. These systems provide real-time weather monitoring. Now it's even available on our smartphones that you can monitor the weather using real time. There are apps available, and hence it provides information on parameters such as temperature, humidity, pressure, wind speed, precipitation rate, wind direction, along with weather forecast, which keeps farmers updated and enable them in taking reliable steps based on the condition of the crops. Soil mapping is another very important tool. So if you are using such systems, soil health can be monitored, and essential soil nutrients and chemical parameter, including soil salinity, electrical conductivity of soil, precipitate rate, pest emergence, and pH of soil for particular crops can be measured. Soil salinization impacts refer to the reduced crop diversity, corresponding food variety, decreased crop yield, induces the risk of floods and soil erosion, and decreases biodiversity. So soil salinization is very, very harmful to the yield of the crop. So the system helps to retrieve data with multispectral satellite imagery and NIR bands for remote sensing analytics of water absorption, and it is linked with soil health parameters. These intelligent tools offer vegetation mapping along with root zone moisture analysis to highlight the difference in vegetation health and identify areas with the bare ground surface. Timely scouting of such zones allow farmers to eradicate the root cause and tackle the issue before it gets very severe. So, this timely scouting can be done using these IoT devices. Another thing that you can do using these tools is water and irrigation management. Using predictive analytics and crop monitoring zoning feature help to drive precautionary inputs to ensure any water related issues that never occur. So you can prevent these issues using predictive analytics and crop monitoring zoning features. Other parameters such as amount of water, the right choice of irrigation method, selection of pesticides, and optimum time of its application, crop rotation, maintenance of vegetative cover could be defined using data insights. Hence, the destruction of the fertile layer of land and soil erosion can be decreased. And farmers can make well-informed decisions on the right course of action at the right amount of time. Whether it's targeted application of fertilizer, minimizing polluting runoff threat, and early indication of irrigation issues to reduce water wastage can be done. Now, there are many current practices of smart farmers application in Pakistan that are available. One is Sawi. It's an app for farmers. It's a platform that provides a distributed network of agricultural monitoring in Pakistan. They combine geospatial data with the power of machine learning and IoT devices to provide smart and sustainable solution to the farmers. Another one that is in use is Bakhabar Kisan. So Jazz Bakhabar Kisan is a dedicated app that helps farmers to increase their crop yields with updated information and technology. This information through this app covers everything from soil preparation to post-harvest, along with livestock and weather updates with audio, video, and pictorial presentations. This app indicates how private organizations such as Jazz, which is a mobile company in Pakistan, can contribute to revolutionizing the concept of agriculture in Pakistan. Then another app, AgriSmart. This is launched by Punjab Public Management Reform Program, PPMRP, for extension worker with a wide range of services, including farmer training session, pest warnings, monitoring agricultural inputs, soil sampling, and receiving complaints. This app is going to digitalize the work of extension worker, which means more easily accessible and fast service for the farmers in Punjab. Punjab is a province in Pakistan. Kisan Sarzameen, another app. It's a health analysis app that provides multiple services to farmers, which includes the use of multispectral images from satellites. Soil condition, crop health analysis, weather updates are provided through this app, making it one-stop digital solution for the farmers. By using this app, the user can detect crop stress at an early stage, benchmark cross performance, and monitor the growth of the crop. Also, the farmers can request drone spraying and mapping services, which digitalizes the agricultural sector and helps the farmer to increase the yield. So that's the end of my presentation. Any question is welcome. Let me conclude by saying that there are technologies available, there are apps available. The problem is with the adaptation. We have to train our farmers to adapt such technologies and make use of these technologies in a right and useful manner. Thank you.
Thank you so much, Engineer Moaz. It was really a wonderful presentation given by you. And now, if anyone has question, he can ask and or put your question in chat box as well. So we will wait for a few minutes, 1 or 2 minutes. If anyone has question, they can ask.
And let me also tell that those farmers or those friends who want to talk, who want to ask questions in Urdu language, may ask me question in Urdu language as well. If there is no question, there can be comments, there can be anything you would like to share with me. I would appreciate that.
Currently, I think we don't have any question for you in WhatsApp.
Sorry, there is just one question popped up. So I would like SMEDA to answer this question, because this is related to training available for farmers in Pakistan. So I would like SMEDA to answer this question, please.
We receive a question from Helena Khan. Okay, yeah. Basically, we are conducting some trainings on the behalf of SMEDA-UNIDO, and basically,
Mr. Harun, you are not audible. Sorry, your voice is cracking.
Am I audible now?
Not very clear. I'm sorry. Let me tell to Ajahn Sebastian that SMEDA stands for SME, Small and Medium Enterprise Development Authority of Pakistan. So that's their SMEDA. So they are working on capacity building for various industries in Pakistan.
Hello, am I audible now? Can you hear me now?
Yes, sir, but still,
I think so. We have an internet issue over here.
now
So
it's
maybe
okay. Mr. Harun, now it's okay. Very okay. Mr. Harun, please continue.
yes. Can you hear me now clearly?
Loud and clear, sir.
Yeah, okay. Sorry for disruption. Basically, it was a glitch here. So basically, we have conducted some trainings programs, and for capacity buildings, we have conducted many programs regarding renewable energy sources and energy efficiency. So in future, we are trying to bring more awareness regarding the implementation of renewable energy sources for specifically for farmers as well. So currently, we are only organizing some seminars and with the collaboration of different chamber of commerce as well. So in future, we will try to implement those renewable sources and those energy efficient measures for farmers in future with the collaboration of dairy associations or some association who are working in the domain of agriculture in Pakistan, obviously. So yeah. Anyone have any question here? So I think we should close this session now. Thank you, Muasab. It was really good presentation from you. And inshallah, I hope we will, in future we will do more trainings program regarding renewable energy sources and the energy efficient measures, especially for SMEs in Pakistan. So thank you so much to all of you for participating us and to giving your time. Thank you so much.
And if someone needs to ask me question in Urdu or any discussion in Urdu language, I am here.
Sir, I think so. We don't have any question right now, but in future, maybe later, if anyone have question, they can directly email to us on ftx.org, or even you can, if you have any question for from our trainer, then you can email to him as well. Master, do you have right email on your presentation? And one and announcement is all for the participant that the presentation will be available on our official website within 2 to 3 days, and the recording of this webinar will also be available on our YouTube official page of SMEDA Pakistan. So I think it's all for now. So we have some international participants as well. So once again, I would like to thank all of you participate. So thank you, Master.
Thank you. So I'm going to write my email, and the one that you will upload on the website will have all the resources available.
Yeah.
So let me thanks all of my friends and those who joined, and thanks to everyone who joined. I hope that you got the chance to learn something new today, and thank you so much for your cooperation and your time.